Alright, so moving on from earlier, we've seen a couple of examples of long division. Now we're going to continue on with a couple of examples of synthetic division. So, this other way of dividing polynomials is called synthetic division. And in order to use synthetic division, two things need to be true. A, the divisor needs to be linear. Okay, meaning the highest power is 1. Highest power is 1. There's no squares, no cubes, nothing like that. Divisor, and remember, the divisor is the thing you're dividing by. So in order to use a divisor, it needs to be linear, and divisor has a leading coefficient of 1. Okay, leading coefficient of 1. So an example of something that's linear and has a leading coefficient of 1 would be maybe like x plus 5, okay, or x minus 1, or x plus 2, and so on and so forth. Those are linear, the highest power is 1, and they have a leading coefficient of 1. So anytime that's the case and you're dividing by something like this, or this, or this, you can use this method of synthetic division that I'm about to show you. So I'm going to go back to what we did at the beginning of the notes here. We divided 5x squared minus 7x minus 6 by x minus 2. Okay? This is an example of a time when I can use synthetic division because my divisor is a linear and it has a leading coefficient of 1. So here's what we do to set up synthetic division. First thing is we put a little box right here. Okay? And inside of that box, we imagine us setting this divisor equal to 0 and solving for x. Or in other words, we flip the sign. If I set x minus 2 equal to 0 and solve for x, I would get positive 2, so that's what I would put inside the box. If this was an x plus 2 instead of an x minus 2, I would put a negative 2 in the box. Okay? So first thing I do, flip the sign on this, stick it in the box. After that, what I'm going to do is I'm going to line up the coefficients of my dividend across the top row. So I'm going to have a 5, a negative 7, and a negative 6. Okay, and then I'm going to put a line right here, and then I'm going to put another box in this bottom right corner. And don't worry, I'm going to do a few examples of this so you can see what's going on. Alright, first things first, we take this number, no matter what it is, and we drop this down to the bottom. Okay, so if that's a 5, we'll drop it down, put a 5 down on the bottom. If that was a 10, we'd put a 10 down on the bottom, and so on and so forth. Okay. Next thing, we take this number and we multiply it by the number in the box. 5 times 2 is 10. And here's where this differs a little bit from long division. In the middle on long division, we subtracted. For synthetic division, we are going to add. So negative 7 plus 10 is 3. And then 3, then we repeat the process over again. So 3 times 2 is 6. Add these two numbers together, we get a 0 in this small box at the end. This box at the end is always our remainder. So in this case, just like at the beginning, when we divided these two numbers, or these two polynomials, 5x squared minus 7x minus 6 divided by x minus 2, we got a remainder of 0. When we did it with synthetic division, we also got a remainder of 0. Now what you might be thinking right now is, what the heck does any of this stuff mean down here at the bottom? Here's how we translate the final answer. Across the top, at the beginning, this was an x squared, this negative 7 was an x, and this negative 6 was our constant. For our answer, what we do is we drop each of these by 1 power. So this was a 5x squared, now this is going to be a 5x. This was a negative 7x, this is now just going to be a 3, it's dropping down to become the constant. And then this number in the box right here is my remainder. So my answer is 5x plus 3, just like I got 5x plus 3 when I did it with long division at the beginning. Okay, so we could once again make a statement that said either x minus 2, or sorry, I should say both x minus 2 and 5x plus 3 are factors of this dividend, because when we divided by x minus 2, we got a remainder of 0. Okay? Alright, we're going to try a couple more, I'm going to show you a couple more examples of synthetic division, and then we'll be done here with the notes. So for our next one, let's try 5x cubed plus 6x plus 8 divided by x plus 2. Okay. Once again, this is a situation where I can use synthetic division because this divisor is linear, highest power of 1, and it has a leading coefficient of 1. Alright, so it has to check those boxes in order to use synthetic. First thing we're going to do, put our little box, flip the sign on this. If this was an x plus 2 set equal to 0, when I solve for x, I would get x equals -2. So I'm putting a -2 in the box. Right? Next up, look at this dividend. There's something special about this dividend. As you're looking at that, what you'll notice is it does not have a squared value. Okay, it goes x cubed, and it goes skips squared, it goes just to x, and then it goes to the constant. Just like in long division, if you skip a power, I want you to put a 0 in place of that power. So across the top, if I'm lining these up, I'm going to have 5x cubed, 0x squared, 6x, and then my constant is 8. And the more you do this, the quicker you'll get at just doing the synthetic division very quickly. We drop this number, we multiply by the number in the box. Okay. In the middle here, we add 0 plus -10 is -10. Multiply these two. -10 times -2 is 20. 6 plus 20 is 26. 26 times -2 is -52. And then in my box here at the end, my remainder, 8 minus 52, is a -44. So what we'll see on this one is this one, we do not get a factor on this one because we do not get a remainder of 0. As I said earlier, later in the unit, we'll just toss this out and we'll try something else. But for now, we're still going to write our final answer. And remember, the powers all decrease by 1. So this was a x cubed. At the end here is going to be a 5x squared. And then everything else just decreases with it. So it'll be 5x squared minus 10x plus 26. And if you remember from earlier, it's going to be our remainder divided by our divisor. So when we're done here, we're going to have plus -44 divided by x plus 2. Okay, there's my final answer to this problem using synthetic division. Once again, we could make a final statement that said x plus 2 and 5x squared minus 10x plus 26 are not factors of this dividend because when I divide, I do not get a remainder of 0. Okay? One more quick example here. It's the same kind of thing. This is just so you can see it multiple times. Let's say we were going to do x cubed minus 7x minus 6 divided by x, let's see, x plus 2. Okay, x plus 2. Alright, just like the last problem, this is an x plus 2, so we're going to put a -2 in the box. And then across the top, we're filling in the coefficients. Notice once again, this skips x squared. So we're going to go 1x cubed, 0x squared, -7x, and a -6. Put our box for the remainder here at the end, and then we'll go ahead and we'll start this process. So we'll have 1, drop the 1 down, multiply by the number in the box, add in the middle, 0 plus -2 is -2. -2 times -2 is 4. -7 plus 4 is -3. And then -3 times -2 is 6. We get a remainder of 0. This started out as an x cubed. Everything's going to decrease by 1 power as we go down the line here. So this would be, instead of an x cubed, it would be a 1x squared minus 2x minus 3. And then we can make a final statement that says both x plus 2 and my answer here are factors of x cubed minus 7x minus 6 because when we did our division, we got a remainder of 0. Okay, and in order for something to be a factor, that means it needs to be evenly divisible into whatever we're trying to divide it into. So in this case, because of that remainder of 0, both of these are factors. And as we move on with this unit, you will see why that is important. Okay, that's all I've got here for long division and synthetic division. Thanks.